Welcome everyone to this new episode of Among Us, human-robot teaming. It's a real pleasure to have a special guest today from Italy, from the University of Siena, Professor Mihai Dragusanu. And it's a real pleasure to have you here, Mihai.
Hi, Filippo. Thank you for the invitation. It's nice to see you and nice to do this stuff together today.
Nice. And I admit that I came to know about your research, and we met through friends. And I think this is also the point of doing research, expanding our network, reaching out. And I was so triggered by your research and the link that I could see with the concept of human-robot teaming. And for our listeners and viewers, I would like to actually read through your biography. So Professor Mihai Dragusanu is an assistant professor of mechanics and mechanism theory at the University of Siena in Italy. And his research actually focuses on exoskeletons, rehabilitation robotics, medical robotics, and assistive soft rigid robotic system, with also looking at haptic solutions. And the aim of his research is actually really close to the core of this podcast, because he's with his team, Mihai is developing and creating robotic technologies that can physically and intuitively collaborate with humans, particularly with applications in healthcare and assistive environments. So his research integrates mechanical design, human-centered interaction, wearable robotics, and haptic feedback to develop robotic systems that can augment human capabilities and improve the quality of human-robot collaboration in everyday life. So this really is echoing with the concept of human-robot teaming, and this really close interaction between humans and machines, with a very specific focus on healthcare. So Mihai, it's a real pleasure to have this chat with you today.
Yes, it's really nice to. Yeah, thank you for the introduction, and for sure it was a really nice time to meet you in ICRA. We meet together there in this conference, this big conference that is, as you said, is really a nice moment when you can meet people and interact with people, understand how is going on in the research in your research field, and understand how it's going around the world. So it was a really nice time there. So thank you for the introduction. And yeah, I think my research field is really fit well your podcast today. So I'm really excited to be here today and to discuss with you those aspects. So yeah, my research is.
I take the opportunity, Mihai, to
Yes.
tell a small gossip to our listeners. You actually got an award at ICRA.
Yes, exactly. I get the award for the young speaker during a workshop on an exoskeleton. So it was a really nice moment. Also that one because I was, let's say, selected among all of those speakers, young speakers, and to be there and won the first prize. It was really amazing to me. Yeah.
Congratulations, Mihai. Very well
Thank you.
deserved.
Thank you. Thank you.
Um,
So, just a few words. Yeah, my research fit really well with this podcast. So, I think today we can have a really interesting, let's say, change of ideas that we can also share with your followers, your viewers, and yeah, for all of the community of the research community, let's say.
that's exactly the point of this podcast: sharing and reaching out and teaming with other researchers.
Yes.
Um, and to me, actually, the visual vicinity with Siena is down to my heart, because I was studying there. I still have many friends, and it looks like that this connection is just continuing and expanding over time. New friends are coming, and it's nice to keep this collaboration going.
Yeah, I think it's also the nice things of the to be in the academic field, because you are able to make research, you are able to meet people. It's always a dynamic world, so because it's always you are changing the things that you have to do. So because you have to be innovative, so it's really nice. And also to keep this connection in between people, it's always a really pleasure. Also to me happen a lot of time because I'm also working with people around the world, for example, from Khalifa University, from India Institute of Technology, from people in Europe, so in Germany, in Spain, in UK, and so on. So it's really nice because in this way you can at the same time work and do something that you really like, and at the same time you can know everything about the culture and everything about the what is let's say the world itself. No, so I think working in this academic field it's really nice and a good opportunity also for the students maybe that are now listening to us. Maybe they can let's say take into account to make a PhD in order to have all of these possibilities, so to see the world and to see how nice it is to work in this area.
See, I'm sure there will be listeners that will be inspired by these words, Mihai. And regarding the core topic of the podcast, this idea of human-robot teaming, I always remind myself, and I always like to remind ourselves, that there are three essential enabling technologies to make this happening. So one is to design better sensors, so sensors that should be placed everywhere, not just on the robot, but also on the human in the environment. So sensors are like this idea of ubiquitous sensors. And the second point is better actuators. Better actuators means actuators that are not more rigid anymore, but they are hybrid or soft rigid, because we are going to have this vicinity, such close interaction
Yes.
between humans and machines. So this idea of having soft actuation is another key element. And then the third element is better algorithms that can adapt dynamically to what is happening. And within your
Yes.
research, you have explored one of these core points, in my opinion. So, for example, the idea of developing soft, rigid exoskeletons, and the idea of augmenting human capabilities through these devices that you are designing, and with the
Yes.
specific focus on supporting rehabilitation. So I would like to
Yeah.
have a chat about this
Yeah,
with you.
yes. Yeah. This is a really nice because a really nice topic because it's, let's say, the core of my research at the end. Because I want to tell you something before I'm starting to go into detail about my actual research, because I think it's nice to tell this story. No, I started to love robotics when I was in my bachelor, and I was almost at the end, and I had to do my thesis. So I started to do the thesis with the Professor Domenico Pratichizzo here from Siena University. And the thesis was about this wearable device that was an e-cap at the end that was able to track the motion of the head, and combining it with the motion of the frontal muscle, I was able to control a robotic arm. So from that point, I understand that robotics for people with disabilities, because you have also to know, I mean, you already know, but I am an end user at the same time. I'm a researcher, but also an end user because I'm affected by disability problems. So I have mobility impairments. So from that point, I understood that the robotics is really important for people with disabilities, because in somehow can give to that people the possibilities to be useful to the society, no? Because I understand from that point that just a simple action that was pouring a glass of water and doing it by myself through this robot, I understood that well, then I should have to develop something that can be used by people with disabilities, and at the same time, the people with disabilities should not feel that are disabled. So, in somehow should be something that let the people feel that are useful to the society. So, from that
This
point,
is
I
a beautiful concept, like this level
yes.
of transparency.
So from that point, I continued my path of study. So I did my master and everything, and then I started my PhD. I started my PhD by immediately starting working on exoskeletons because I started to think what is the field that can allow me to let the people helping another people, but the people that are also with disability. So the topic was is the exoskeleton topic. So this is why I started to work on exoskeleton, and indeed my master thesis was on an exoskeleton for the wrist. And at that time, when I started my PhD, I continued to develop those exoskeleton for the wrist. Then I passed to the hand. But at that time, I was working with the rigid solution. No, so the idea was to have a device that was for sure for rehabilitation purpose, because in my opinion, having robotics really help in the medical field because it's important because at the same time could, let's say, help the physiotherapist to increase the strength, can for sure in somehow help in the rehabilitation path and make it more faster, and at the same time could be tailored for each user. So uh, this was my direction when I was started to work on this field, and indeed I developed those exoskeletons. And I developed in such a way that mm, at that time, the idea was to make it easy to wear and at the same time to use it for a prolonged usage. So during the day and so on and so on. So I meet different requirements, but then there was a requirement that is really important. That is the force that you have to give to the user, no, at the fingertip at the end. So in order to have that force, otherwise, you have to fight with the motors because the force are given by the motors. But if you have to apply big force, you need big motors. So it means you have something that is really heavy. So at that point, I realized because after times that because I took the device, I took it home, I started to use it every day, and then I realized I don't want to wear it. I don't want to wear it because it's heavy. It's heavy, and I cannot wear for 1 hour, for example, without feeling pain on my hand. Because on one side, yes, it's good because I can do the rehabilitation from home because that device, that system was able to track the motion of the hand, to track the motion of the wrist. And then there was also the possibilities for the physiotherapist to control from remote the profile. So it was nice from that point of view. But at the same time, I realized that, okay, I don't want to wear it because it's too heavy. So I think this is the first key that somehow pushed me to change the technology that I'm using for the exoskeletons and to pass to the soft part, no? Then I realized, okay, but okay, soft could be really nice and everything, but you need still the actuation. So the actuation at that point, if you are using soft, somehow you have to use tendons or pneumatic or something hydraulic. So if you are going to use that kind of actuation, for sure you have another box, another stuff that you have to carry with you and everything. So this is why I started to think about a solution. And the solution was those twisted string actuators. The nice things of these actuators is that you can use small actuators that thanks to the twisting of two or more tendons, you are able to apply force. But in this case, it's not anymore the motor that is applying the force, but is this twisting action of the two strings or three or four as many you want. There is a mathematical model that you can use and everything in order to decide the force that you want to have at the fingertip. And then I started to integrate this, starting a collaboration with Khalifa University and another guys. We developed the first module of a big project that I'm working also now. That is an suite that is a big project that includes the hand, the wrist, the elbow, and the shoulder. So at the end, what I want is to have something that I just wear like a t-shirt and I just want to use it. And then this is why I passed from rigid to
Like
soft.
the costume of a superhero, right?
Exactly,
They are
something like this.
wearing and become
Exactly.
Superman,
Like Iron Man, but
Iron
soft.
Man.
Exactly. So was and then from there I started to develop those solution, and that now we have almost complete all of the parts of the human arm, and yeah. So this is why, from my point of view, combining then let's say, because as you can understand, the actuators need some support that should be rigid and fixed to the parts of your exoskeleton suite. So in that case, for sure, you need some solution that is soft and rigid, and this is why I'm going in this direction.
So you
But
get
yeah,
the best of the two worlds, like
yes,
strong.
exactly. Exactly.
Uh,
You have at the same time enough power, but at the same time, it's not so heavy. So the actuation is adapting to yourself at the end because it's soft. You are using tendons at the end. And then let's say the problem here is just the anchor points. So also in this case, we develop different solution. And I can say that this is an really good direction because as you can see in our idea world for me, what I want to do is to have an room in which I can go inside, I can choose my exoskeleton, and then thanks to this exoskeleton, I'm not disabled anymore, let's say. So, because in my opinion, the disabilities at the end can be seen that is in the technology itself. Because
you're
for,
using technology to
yes, exactly.
cancel or compensate disabilities. Yeah.
Exactly, because I can say to you, no, you are wearing a glasses now, no, because you have problem with the with your eyes, no.
Hmm.
But if you are not wearing it, you are disabled.
Yeah. Actually, like for
So
example, one example I like to give my classes when I teach exoskeletons and in my course of biomechatronics, it's exactly this. I ask the class, many of you today are wearing an exoskeleton or we can call it prosthesis or some augmenting tool. Like this is one, the glasses, and then there's another one even more common that everyone is wearing every day, our shoes, right?
exactly,
Uh,
and and indeed, then we can say that the disabilities can be seen that is in the technology. When maybe in a near future, but maybe not. But maybe we can have this technology that can help us not to have a disabilities anymore. So at the
nice.
point, is this my let's say vision at the end, and I would like to see it one day. So yeah, at the let's say the physical human robot teaming in this case is really important at the end because I think is the core, no? Because in somehow you have an extension of yourself because if you can choose and then if you have a disabilities and then thanks to the device you don't have it anymore, then for sure it's something that is you at the end. Also the robot itself, it becomes you. So it's an extension of yourself.
Very nice, very deep and actually philosophical approach. And with this, I think we also understand the need for an interface between humans and machines that needs to be as much as possible intuitive, transparent, so that we can give full awareness to the human and also shared awareness between humans and machines and trust between the two players that become one, as you said. And in your research, you have explored, among other things, also haptics and haptic interfaces. So it would be nice to know a little bit more about this as well.
Yes. So yeah, for sure, as you said, the interface in between human and this device that at the end is yourself, it's really important. It's really important because at the same time should be something that the user should not care too much about, but just this interface should be ready to play, let's say, because at the end should control this device, but should control based on your intention. So I think yeah, the haptic is really important. I want to tell you something. During the ICRA conference, I was also involved in a workshop that was on human augmentation made by Professor Domenico Pratichizzo and the team. And I was involved in a demo live demonstration there where the idea was to, uh, let's say, use the residual motion of an user with disability in order to control a robotic arm to do a simple task like split the cream on the forearm, okay? And this control was made thanks to a tracking system plus an haptic interface. Okay, the haptic interface was able to give me vibration and also pressure in order to understand how to control this robotic arm. And I want to give you my personal experience, and also because end of user, so I think it's something that could be useful also for who is listening us today. um, I when I wore this wearable device, this haptic device, okay, I started to then to control this robotic arm that was spreading this cream on my forearm, okay. Uh, at the beginning, I was starting to look at the robot arm because it was really near to me, no? And I was scary about it because I said, okay, come on, okay, we are controlling, we are researching, but as you know, as usual, the demo will not work in real time, no? So I was scary, and I was starting to move my residual motion of the hand, and I was spinning this cream on my forearm, no? But I was still looking at it without trusting the haptic at the beginning, okay? But after a certain time, I started to look at the people on the room without looking anymore to the robot, but just feeling the robot that was spreading the cream on my forearm, okay? So this is just to tell you that it's really important to have an haptic feedback and so have an interface in between human and robot. The personal experience that I had during this demo live demonstration was this: that at the beginning I was not trusting the haptic interface, but then yes. So it means, in my opinion, we should work more in this direction and in somehow also integrate the AI model just to help you in control better those agents that I can say that is in the environment that you are with them, let's say, no? So this is really important things because for sure the safety should be in somehow ensured now by your system, and this really could be an let's say an tool that can help you to control and also to be, let's say, safe, because in this way you can communicate with the robot, because as you know, usually the human, how they are let's say interact, usually there is this physical interaction, no, in between humans, and also you are using your eyes and your tactile sensors, let's say the hands and everything. But with the robots, how you can communicate through a haptic interface. So having this haptic interface with force, with vibration, also can give you temperature feedback. Uh, for sure, augment, no, this communication between human and agents or robots or cobots on exoskeleton and so on. So I think an wearable haptic system is really important because you don't, I mean, the robot don't have visual attention now because at the end, the robot is there, is a robot. But thanks to this haptic interface, in somehow you are speaking the same language of the robot.
Mhm.
So this is the point. So yeah,
Yeah, this is very
I
interesting concept, and you mentioned two important things in my opinion. One is this trend of that is almost unavoidable, like to merge together. It's like a complete integration of sensors, actuators, and interface together, glued through the software. And now, finally, we are in the age of AI, where algorithms are actually going to really be so powerful. And I believe that we are at that stage where this full integration is very, very relevant. And then the last point you mentioned is the importance of touch as a really strong way to connect humans and machines. So I think that this is very, very in line with the theme of human robot teaming. And I would like to also ask you about a little bit more in detail what kind of applications you have explored, some specific rehabilitation procedures, and what is the operational procedure that you have considered.
Yeah, yeah, yeah. As you already mentioned, and also during the introduction part, I'm working a lot in the rehabilitative field. So, for sure, when I developed the exoskeletons, I developed also interface in order to work in that direction. In my opinion, and also during my, let's say, application that I developed, the most important things that should be taken into account is the, let's say, personalized assistance. By means, what does it mean? It means that you have to develop solutions that are in somehow modular, that are tailored to the users. So it means that those devices should be able to adapt to the users. So this is why the application that I develop always take into account the modularity. So the modularity, in my opinion, is really important aspect of exoskeletons because, for example, if I want to perform rehabilitation only for index finger, I should be able to do it just for the index finger without wearing all of the fingers. I just
Mhm.
want to wear the index finger. Same things for the wrist, same things for the elbow, same things for the shoulder. Okay, so this is the direction that I'm going now, and is this exoskeleton suite in which I'm able to decide in between which part of the body I can use, and the interface that I'm using is an interface based on tracking system that is made by two emus plus an AI that can understand the intention of the users. So it means if you want to do a rehabilitative session, then you have the physiotherapists that will move your, for example, let's take the wrist, will move the wrist, okay? Perform, for example, a flexion extension motion. You have a profile, you can reproduce it by using this learning mode algorithm, okay, that we have implemented. And then you can perform it at home how many times you want, how many fast you want, and how many times per week. And this will avoid you to go every time in the center. Okay. And
So
so
this is already
it
like
means
saving time,
exactly
saving
saving time
cost.
because, as you know, we have in this world that time is really important for everyone. So, for sure, also because I'm end user, going to the rehabilitative center is somehow annoying me. So I want something that I can do whatever when I want, and at the same time, I can also decide how to do it. So this is why I went in this direction, and I developed this interface. But at the same time, you have also this device that is able also to assist you. So in order to assist you, we implemented this algorithm that is based on an AI system. This AI system, it's able to understand your intention. For example, if you have to do the flexion extension of the wrist, you have just to start the motion, and then the exoskeleton will continue for you. For sure, this idea allow you also to use the exoskeleton in a training mode. So the exoskeleton will work against you. And so those are let's say, the application and the things that we are now developing for the point of view of the exoskeleton. Then we have also application for concern haptics. Also, in that case, in that scenario, we're working with haptics still for the rehabilitation purpose. We developed different solutions, wearable that are working for the palm and also for the finger, and also desktop application where you have just to put your hand on it, and there is an mechanism under this pad that will apply pressure and temperature on a specific area of your palm. So all of those solutions still was done in order to help you in the rehabilitation path. So then also, as because the topic is human-robot collaboration, I also develop a solution with grippers. Grippers where those grippers are able to adapt, let's say, to the interaction with user, thanks to the changing of the stiffness of the fingers that are used for those grippers. And yeah, we also developed different solutions also in that case. And one nice solution that we developed is this gripper, two-finger gripper, that thanks to two magnets, when the electromagnets, when there are, let's say, you close the finger and you activate it, you are able to grasp a t-shirt, for example, and the robot will collaborate with you and help you in wearing it. So this was one of the nice things that we developed. Then for sure now we are developing different solutions, and I'm trying to integrate the soft actuation of the TSA inside these grippers. So it's nice because thanks to the TSA, I can also varying the stiffness of a finger. So I'm starting from the exoskeletons using that kind of actuation, and now I'm using it also in grippers. So it's really nice to see how a solution could adapt to different field for robotics. So different things that we are going to, we are still going to develop in our lab.
This is the beauty
And,
of ideas. If the idea is
yes,
good enough, you can reuse it. And
yes, exactly,
also, like,
yes.
I really appreciated the point where you mentioned the use of AI to detect the intention of the human. So this is very much at the core of the concept of human-robot teaming. And we have a song that is going to play at the end of the episode, and the lyrics is actually touching upon these topics, these ideas of when we are teaming, we are stronger when we are teaming, and we need to understand each other. And I think that what you're doing, even from an application perspective, is actually really exploring this concept. And I think that this brings us nicely to what we can look in the next years to come. Like, what is your vision? So, for example, we have highlighted the aspect of, let's say, intrinsical teaming between the human and the exoskeleton. Then you also mentioned other actors involved. You mentioned the physiotherapist, of course, the end user itself, which is the core of this research focus, the machine itself. So there are multiple users involved what is your vision also for the future? For the future, to have this hybrid team together.
Yeah, this is a really nice, let's say, question and also topic to discuss because, yeah, my vision is that um, I think there should be a need of changing the paradigm that is now. No, because at now, let's say the interaction is one to one. Also, okay, so it means that you have the exoskeleton, you wear it, and then you try to use it, and then maybe there will be the physiotherapists that will help you to use it, and so on. Okay, but my vision is a little bit different. In my perspective, I can see the exoskeleton of the future, that is an exoskeleton able to stay in an environment, to adapt to the environment in a dynamic way. So what does it mean? It means that the exoskeleton will somehow start to have a skin, start to have a skin that is able to feel what happened around the exoskeleton itself. But at the same time, we should not have to lose the fact that the human should be at the center. So it means that the exoskeleton is a layering between human and the environment, but still is the human at the center of everything. And then at that point, if the exoskeleton is able to understand in which environment it is and in which the exoskeleton is living, it means that then can collaborate with another exoskeleton. Then at that point, it means that not only to the exoskeleton, but also with another cobot, for example. If we are going to think on industrial application, imagine to have this exoskeleton that will help the workers not to perform the task and everything. But this exoskeleton is able to understand at the same time the intention of the user, but also to communicate to the cobots that is inside the industrial environment. So in somehow collaborating in performing tasks. But not only this, imagine also the rehabilitative scenario. Till now, I tell you about the aspect that, okay, I want to bring the exoskeleton at home and I will perform the exercise by at home alone. Okay, but let's try to think instead on changing the paradigm. Okay, you can do this at home, but why not to go in the center and perform the rehabilitative session with another user that are wearing the same exoskeleton that is able to communicate in between each other? I think it's something that could be explored because in somehow you are feeling that you are in a community, no? And at the same time, there will be for sure physiotherapists that will control the exoskeleton, but the exoskeleton is able then to understand your intention, but also to communicate with the other exoskeleton to perform a rehabilitative session all the people together. So my feature in this direction for sure will be exoskeleton with some kind of skin that can feel what is the environment, and at the same time, this exoskeleton is able to communicate with another exoskeletons, but also with another cobots. And third, for sure, there should be this AI that will allow, in somehow, the user to control the exoskeleton and the exoskeleton understand the intention of the users. And for sure, also the intention to the other user. So you have this exoskeleton that is really dynamic and can adapt to really to each situation in every moment and in every environment.
Beautiful. I think that yeah, this covers this almost like a transition from a one-to-one team, just the
Yes,
human and the exoskeleton, to a one-to-many, like a collaborative rehabilitation
exactly.
environment. That's, I think, also from, as you said, from a psychological perspective, will have an impact on the effectiveness probably of the procedure itself, because then you have more motivation. You have
Exactly.
also like more you are more willing to work with the others. So that's really nice.
Yes,
And
at the end is sharing, sharing a task with someone else every time, and you have the possibilities to choose at this point to what you want to do and what you don't want to do. And at the same time, at this point, you are not constrained to be alone at this point at home, but you can choose.
Very, very nice. And also the applications for industrial, from an industrial perspective. And then really, it goes again back to the point that you mentioned at the beginning of the episode, the possibility of canceling or hiding the disabilities, or the possibility of augmenting capabilities for humans. So like really like wearing a t-shirt, as you said, or a shirt, and you become a superhero. Uh,
Exactly.
so I think that this is a
Yes.
really nice vision to
I
this vision.
hope in the next world, I mean, in the future, in the let's say the next, really next world, this could happen. And yeah, in somehow the disability should not be seen anymore inside a person, but maybe it's better to see it in the technology. And for what concerns the industrial workers, for sure, this could be a really good improvement, because we can also think about the age and everything that and the problems that can come with with the age. And in this case, we can avoid, and at the same time, we can have everyone. We can have a really good life and a better life for everyone.
Very, very beautiful message. So it gives hope, and we believe that with our small contribution to this vision, this chat has helped us to understand a little bit more about your research and about your vision and about the possibilities that the technology today is offering. I'll just remind everyone that I will add links and references to your articles, Mihai, so that if anyone wants to go a little bit more deeper into these topics, they can do it. And I also
Yes.
take the opportunity. You mentioned ICRA. We mentioned ICRA several times. To our listeners that might have missed the previous episode, was recorded at ICRA. So go and check it out, that episode. And you also mentioned Domenico Pratichizzo, which was also my supervisor, and he's going to be invited in one of the next episodes. So Mihai, thank
Nice.
you very
I
much
think
for your
I
please.
think you also invite as a speaker Monica Mardezzi, that it was my supervisor during my PhD, and I'm now working with her on those aspects. So
She's on my list. Yeah,
yes,
she will be.
exactly.
And we have a conference coming up at the end
Exactly.
of June. She is going to visit us and as a keynote speaker.
Yes, exactly, exactly. She mentioned me today about this. Yes.
It's a small world, and it's nice to connect. So Mihai, thank you very much for your nice chat and contribution to this. We really look
Thank you,
forward.
Filippo. I hope that this will be useful for your followers, for the people that are listening to this podcast, and I hope my perspective that could be both, no, from the user point of view and user point of view, and also from the research point of view, could be in somehow useful for all of them.
Thank you very much, Mihai. So, and then I leave everyone with our closing song, and remember that we are, or they are, among us, and we are human robot teaming. Thank you, everyone.
Thank you.
among us, not alone in innovation. Share control, share creation, rewriting our design. Human robot teaming. Human robot teaming. Through the noise of doubt and distance, through the fear of what may be, we found trust in every motion, in shared autonomy. Not replacement, not surrender, but a fusion of design. Intelligence extended, your decision joined with